Hi guys, today we are going to learn about Cauchy's integral formula, which is in your unit 4, and then Cauchy's residue theorem. So the Cauchy's integral formula says if f of z is analytic inside and on a simple closed curve C. So your curve can be anything of this form. Okay, and it is a closed curve. So C I am taking, and R is the region enclosed by the curve. Then A is a point, it should be inside or else it should be on the curve C. Okay, then f of A is given by 1 by 2 pi I integral over C f of z dz divided by z minus A. So this is what we call as the Cauchy's integral formula. Okay, the same formula can be expressed as f of A into 2 pi I. So I'm taking 2 pi I to this place. So it is 2 pi I into f of A. So that is equal to integral over C f of z dz divided by z minus A. The main condition is that the point A should be either inside the closed curve or it should be on the curve. That's the condition. If it is outside, suppose the point is outside the closed curve, then without calculating you can write the value of the integration is equal to 0. Okay, clear? So if that particular point A is outside the closed region C, then the value of this integration will be equal to 0. So the main condition you have to remember is the point A should be inside the closed curve C, which is given in the problem. So similarly, the Cauchy's integral formula for derivatives of an analytic function is given by fn of A equal to n factorial divided by 2 pi I integration over C f of z dz divided by z minus A whole power n plus 1. See, I can write the same formula as fn of A into 2 pi I divided by n factorial equal to integration over C f of z dz divided by z minus A whole power n plus 1. See, when you have to use this formula, means see your denominator with the problem with the formula 1. See, if it is of power 1, then you have to use the Cauchy's integral formula. If it is of power more than 1, you have to use the Cauchy's integral formula for derivatives. Okay, you have to use this Cauchy's integral formula for derivatives. So let us see problems based on these two. See, to begin with, I'm starting with a simple problem. Evaluate integration over C dz by z plus 2, where C is nothing but the closed disk, the modulus of z equal to 1, which is nothing but a unit circle. And it is by using the Cauchy's integral formula. We know that the Cauchy's integral formula states that integration over C f of z dz divided by z minus A equal to 2 pi I into f of A. See, now this is the general formula. Let me take it as equation number 1 and let our problem be integration over C f of z. F of z is considered as 1 here because there is no z term in the numerator, and divided by z plus 2. So I can write this as z minus of minus 2. So from this we conclude that z is equal to minus 2. Now you have to check whether this point is inside the closed region. See, when I put z is equal to minus 2 in modulus of z equal to 1, then minus 2, this is not at all less than 1, but it is greater than 1. That means what? Z equal to minus 2 is not inside C. Therefore, you will get it as, therefore, the value of this integration is equal to 0. Let me take another problem. Integration over C e power z dz divided by z minus 1, and let us take that C as C is modulus of z equal to 2. So from the first formula, see, it's very clear. Your f of z is, here f of z is what? E power z. Okay. Therefore, and your z minus 1, see the denominator, z minus 1 implies, compare it with your z minus a as in the formula. So this implies that a is 1. Therefore, by your 1 equation, by the Cauchy's integral formula, what you will get here, the I equal to, I is nothing but the given problem. It is 2 pi I into f of a. So 2 pi I into, what is your a here? A is nothing but 1. So I'll get it as f of 1. You know that your f of z is e power z. Therefore, this is equal to 2 pi I into e power 1. So what is e power 1? It is E. Therefore, the answer is 2 pi I into E. So this is what we have. So here the condition is the 1 is inside this closed disk, whereas in the previous problem 2 is not inside the closed disk. Even by just by seeing that, you can conclude that the value of the integration is equal to 0. So these type of problems will be asked in 2 marks. Let's start with the third problem. Evaluate integration over C sin pi z squared plus cos pi z squared divided by z minus 1 into z minus 2 into dz, where C is modulus of z equal to 3 by the Cauchy's integral formula. So Cauchy's integral formula is nothing but integration over C f of z dz divided by z minus a equal to 2 pi I into f of a. The condition is a should lie inside the curve C. So in our problem, our f of z is the numerator, which is nothing but sin pi z squared plus cos pi z squared. Let me take the given problem as I. See, and if you want to apply the Cauchy's integral formula, the denominator should be a factor. So there are two factors in this, so we have to separate them. So in order to separate, we apply the partial fraction method. Therefore, let me take the denominator with the 1 that's in the numerator. 1 by z minus 1 into z minus 2 equal to a by z minus 1 plus b by z minus 2. Therefore, you will get 1 equal to a into z minus 2 plus b into z minus 1. So when you substitute z equal to 2, we get b equal to 1. And when z equal to 1, we get a equal to minus 1. Therefore, the integration is splitted into two, one with the denominator z minus 1 and another with the denominator z minus 2. So therefore, I can write this as integration over C. What's the a value? It is minus 1 into sin pi z squared plus of cos pi z squared dz divided by z minus 1. This is one term plus b into, or b is 1 into sin pi z squared plus of cos pi z squared into dz divided by z minus 1 in, z minus 2, because we have taken the first term here. Okay, so now in this I can write this as minus 1, and here you know that the f of z term is a sin pi z squared plus cos pi z squared. Now check whether this 1 is inside the C. What is C? C is modulus of z equal to 3. Therefore, you will get this as minus 1 into 2 pi I into f of 1. So because our a value is 1 here, and this is expressed as b value, that is 1 into 2 pi I into f of 2, because here a is 2. Therefore, I am going to apply which formula? The Cauchy's integral formula. So that's why we got it as integration of f of z dz by z minus a equal to 2 pi I into f of a. Here a is nothing but 1. So f of 1, here a is nothing but 2. I am having it as f of 2. Okay. So now we have to find what is the value of f of 1 and f of 2. Okay. And you know that f of z. So from this I can substitute. Suppose if I take this as equation number 2, in this let me substitute z equal to 1. So it is the sin pi 1 squared plus cos pi 1 squared. You know that sin pi is 0 and cos pi value is cos n pi is minus 1 whole power n. So here n is 1, so I'll get it as minus 1. Okay, and what is for f of 2? F of 2 is nothing but a sine of pi into 2 squared, because z is taking the value as 2, so 2 squared plus cos pi of 2 squared. So I'll get it as 2 squared. So this is sine 4 pi and cos 4 pi. Sine pi is sine 4 pi means it is again 0. Cos of 4 pi, you know that cos n pi is what? Cos n pi is minus 1 the whole power n. So for cos 4 pi means it is nothing but equal to minus 1 the whole power 4. Anything to the negative term, the even power is always positive. So I'll get it as plus 1. So in the place of f of 2, substitute 1, and in the place of f of 1, substitute minus 1. Since already you have a minus 1, minus 1 will become plus 1. So this is the plus 2 pi I, and your f of 2 value is again, you know that f of 2 value is 1. So if I substitute this as 1, so I'll get this as 2 pi I into 1. So the final answer is 4 pi I. So for this particular problem, we are having the answer as 4 pi I. Next problem, that is evaluate integration over c z squared dz divided by z minus 1 the whole square into z plus 2, where c is nothing but modulus of z equal to 3. So we have to solve this by Cauchy's integral formula. So in this we know that integration over C f of z dz divided by z minus a equal to 2 pi a into f of a. So this is for this factor, and you see here it is more than, the power is more than 1. So certainly we are going to apply Cauchy's integral formula for derivatives also. See, now as of now there are three factors here, that is z minus 1 the whole squared into z plus 2. Okay, so we have to apply the partial fraction for separating them into factors. So z squared by z minus 1 the whole squared into z plus 2. So you see, if you feel, if you want to take this as f of z, then take that partial fraction as 1 by z minus 1 the whole squared into z plus 2 alone, and go ahead as such. You can take z squared also in the numerator. It's another way of doing. So either you include z squared, so in that case your f of z will be without z squared. Okay, got it? It will be 1 in that case. So now z squared by z minus 1 the whole square into z plus 2 is a by z minus 1 plus b by z minus 1 the whole square plus c by z plus 2. So let us write this as z squared is equal to a into z minus 1 into z plus 2 plus b into z plus 2 plus c into z minus 1 the whole square. Substitute z equal to 1. So we will get b equal to 1 by 3. And if we substitute z as minus 2, we are getting c as 4 by 9. And by comparing the coefficient of z squared, we got a as 5 by 9. So I can write this as, say, remember I have taken already z squared, so now there is no f of z in our problem. So this integration is equal to integration over c of a is nothing but 5 by 9 dz divided by z minus 1. This is the first integration. Next, integration over c of b value. What is b value? Which is 1 by 3 into dz divided by z minus 1 the whole square plus c value, which is 4 by 9 into dz divided by z plus 2. Okay, so here c is nothing but r modulus of z equal to 3. Both the values 1 as well as 2 lie inside modulus of z equal to 3. And for this we are going to apply the Cauchy's integral formula for derivatives. And for these two we can apply which formula? The formula number 1. So what is the Cauchy's integral formula for derivatives? The Cauchy's integral formula for derivatives is given by integration over c f of z dz divided by z minus a whole power n plus 1 is equal to 2 pi I into fn of a divided by n factorial. Okay, fn of a by n factorial. See, in our problem, this squared can be expressed as 1 plus 1. Therefore, n value is 1. So I can write this as 2 pi I into f1 of a, because here n is 1. So I'll get it as 2 pi I into f dash of a. Here, see, f of z itself is 1. Therefore, f dash of 1 will be 0 in this case. So let us write this as 5 by 9. Coming to this one, so it is a linear term here. So z minus a is taking the value as 1, and moreover it is inside c. Therefore, you can apply the Cauchy's integral formula, which is 2 pi I into, this is a value, this is 2 pi I into f of 1. F of 1 is 1 here for s. Okay, so f of 1, and this is 1 by 3 into 2 pi I. See, here we have fn of a by n factorial. N is 1 factorial and n is 1. So f dash of 1, it will be 0. So f dash of 1, that is 0 for s, plus 4 by 9 into 2 pi a. Since this is linear, so you can apply this formula, and it is equal to f of minus 2. And the f of minus 2 here is nothing but equal to or 1. There is no function f of z. So our f of z is 1 throughout our problem in the numerator. So you will get this as 5 by 9 into 2 pi I. Then the next term is 0 plus 4 by 9 into 2 pi I into 1. Therefore, you will get this as, simplifying, you will get this as a 2 pi I. So this is the answer for this fourth problem.